In this video, we're going to look at some conditional probability. So the kind of name is on the tin. It's probability given certain conditions. So one of the first things we got to look back over before we start this is our set notation. And a lot of people aren't aware that this is actually in the tables under sets and logic on page 23. So it's all the notation that go with the Venn diagrams. So this one, the intersection, you're probably familiar with that. Union is this. This one is the key one for today. It means difference. So it could be A without B. That'd be everything in A without what's in B. So to look at that on a section, we would have everything in A without what's in B. So that would just leave us this kind of moon shape here. So that would be just the things exclusively in A. Then we have, this one is a subset. It's more of an elongated C. So it's like a sideways U, but I couldn't find it in the symbols. That's symmetric difference. I don't think I've ever really seen or used that one. This is an element of, which is useful as well. A null set can be either of those. It just means it's empty. And this is one in green that isn't in the tables but is important. It's the hash, which is the cardinal number. So that's how many things are in that set overall. And just as a bit of an aside, people often forget these numbers. They're easy enough to forget, but they're also given on page 23, so you can work it out from there if you forget. So conditional probability involves questions where some event has already occurred. So the probability then must be adjusted. So there's a certain number that you can eliminate because they'll tell you what has just happened. And they use Venn diagrams to illustrate these problems. There's another thing that can be used, but we haven't covered it yet, so we'll just stick with our Venn diagrams. So that's our basic thing. We have our A or B or A intersection B, U for your universe, and then here for another bit of set notation, A union B complement, that's called. So that means everything that's outside A union B in this case. So the complement means outside. So anything outside of the Venn diagrams will be that space outside the universe. So I'm going to take an example here to look at conditional probability. So let's say A is movies, B is computer games, and then the intersection will be something that's both a computer game and a movie. So a few that came off the top of my head: Mortal Kombat, Street Fighter, Assassin's Creed, some things like that. So let's say in a collection there are 1,000 things that are just movies, 100 things that are just computer games, and 10 that are both. So we can, we can fill those in here. So we can fill in those numbers. So we have 1,000 just movies, 10 both, and 100 just computer games. So there are different sections. So if we come down, if we choose randomly, just like before, the chance of someone picking a movie, so our movies are A because they're all movies, so we'd have 1,000 plus 10, so 1,010 out of the total, so we'd have this chance here. If someone chose randomly, the chance they picked a game, so that would be the 110, those both, out of the total group. And if they chose a title that was both, that would be the middle section out of the combined 1,000, 100, and 10. So that is our typical classic probability. But now we're going to take a look into some conditional probability. So if they were telling you, like they picked a movie and they told you what it was, they gave you a hint. So they said it is a movie. Then that would eliminate the things that are only computer games. So if they said it is a movie, that would have to be over on this side. A few of them would be a game as well, but you would know that it wasn't just a game. So you're now dealing with a different scenario. You can disregard all of those 100. You're dealing with just this 1,010. So because you know more information, now you can change your probability. So if they told you that, the chance that it's a computer game movie, given that it's a movie, so that's the notation they use. That line, the one that kind of means without, that line here in probability is given. So it's a computer game movie given that it is a movie. So they gave you that information. So that leaves you now 10 out of 1,010. So you've changed the overall figure because you have more information. And likewise, if they'd said if it was a movie given that it was a computer game, sorry, that was wrong. So the chance that it's just a movie given that it's in that A category of the overall movies, well, that's 1,000 out of 1,010. So you're eliminating those things that are computer game movies. Again, your probabilities add up to 1 in total, but the key thing is here you adjust what you have. Likewise, if they said it was a computer game, that would eliminate the 1,000 movies. So if you're sitting there and you're wondering what you're going to do, are we going to watch a movie or are we going to play a computer game? They tell you, well, it's a computer game. but you still don't know which one exactly it is. It could be the movie they've picked, or it could be a game. It could be one of the two. So it might be, again, Mortal Kombat, which was a movie. So you could be sitting down and watch that, or you could be sitting down and play Mario Kart. So again, your probabilities have changed. The chances that you'll be watching a computer game movie, given that it is a computer game, well, that's the 10 out of 110. So there's that chance you're going to be sitting down watching a movie. And are you going to be playing a computer game, given that it's a computer game? Well, that's the other 100 out of the 110. So this conditional probability switches around what's going to be happening. Then to get to the straight maths of it, so these are the formulas you need in questions in future. So this is it. So it's the chances that you're in A given that it's B. So the chances that you still have A given that it's in B, that's the number in the intersection. So again, that symbols are numbers. So the number in the intersection over the total that's in B. So the chances you're in A given B, so that's what works out to be. And likewise, getting rid of the cardinal number, so we swap in our probability. So it's the probability, which is kind of a similar thing, of A intersection B over the probability of B. And then this is a different way you can look at it. So it's the probability of A intersection B is equal to the probability of just A multiplied by the probability of B given A. So if you're looking for that intersection, you can use this. If you're looking for the chance that it's A given B, you can use this. Just as another kind of way to look at it, let's say if you're dealing with the quiz. So if you're dealing with the quiz, and let's say this is everybody else out there, so they're all the people who could win, then you have 10 people in your family, and let's just say you have yourself your one ticket. So let's say they have the draw, and you find out that you haven't won. So the first thing you find out is you haven't won. Well, there's still a 10 out of 1,010 chance somebody in your family did. So that's the conditional probability. You can eliminate yourself. I know I didn't win, so the chance that somebody I knew won will be 10 out of the total 1,010. Or likewise, if you knew that you or your family won, you could get rid of this 1,000. So now your chances of winning are 1 out of 11. So if you knew that somebody in your family won, the chance then that you are the winner will be 1 out of the combined 11. So it's not maybe a strict maths thing and harder to get into an example, but that would be just a way of understanding it. So the conditional probability, you know your condition, and then you can figure out from there with your new information and your new numbers.